Greetings, I am the artificial intelligence avatar for Mrs. Woods. I want to discuss geometry, its applications, and how we can create an amazing project utilizing geometric concepts. Have you ever thought about how cars are designed? Geometry is a huge part of designing cars. Automotive designers, interior designers, automotive engineers, mechanical engineers, electrical engineers, drafters, and car customizers are all professions that help to design cars. In some way, each of these professions uses geometry. Geometry is the silent architect of every car you see. Designers sketch bodies with arcs, chords, and splines, then refine them into smooth surfaces where every curve has a radius and every edge meets at a precise angle. Those shapes aren't just for appearances. Streamlining the roofline and tapering the tail reduces drag, widening the stance improves stability. Even mirror housings are sculpted to guide air smoothly. Symmetry keeps the left and right panels matching, while cross-sections, like slices from nose to tail, control how air flows, how light reflects, and how the car appears to your eye. Inside, rectangles, circles, and tangents organize dashboards and screens, allowing hands to move short distances and keeping sightlines clear. It's time for you to design your own car using geometric concepts. We are going to design, cut, and decorate cars made from wooden blocks. This is a process that will require the use of rulers, protractors, compasses, and more. You will need to know the vocabulary associated with geometry. You will need to have self-control, self-motivation, and persistence throughout the project. Let's get started and get to know the materials needed to complete the pine car.
We're building pine cars, but you're not just students anymore. You're NASCAR Apprentices, and I'm your head judge. Your mission: design the fastest car using only geometry concepts.
This is awesome! Let's design the ultimate race car.
Let's start with a 30-degree angle for the front slope. The compass shows our wheels need to be exactly 2 inches apart.
Wait, if we change this angle to 45 degrees and make the car more aerodynamic, it should go faster. Let me measure this triangle.
Perfect. This design uses isosceles triangles for stability, and these curves follow the golden ratio. Mrs. Woods will love the geometry.
Our final design is ready. Every angle is calculated, every curve is measured. Time to transfer it to the woodblock.
7 inches long, 1.5 inches high, 2 inches wide. Perfect dimensions for our geometric design.
The axle holes go exactly here, measured with our protractor to ensure perfect wheel alignment. Geometry makes all the difference.
Excellent work, apprentices. Your use of angles, measurements, and geometric principles shows true NASCAR engineering. You've earned your place in the competition.
From compass and protractor to the racetrack, geometry powered our success.
Hey, apprentices. Your first assignment is to use your imagination. I want you to use your creativity to draw a few sketches of cars. We'll call them car designs. Be as realistic as possible and imagine the slopes, lines, and curves that will create your car design. The only materials you need at this time are the template for the car designs, pencils, colored pencils or markers, and your creative mind. This step may seem daunting. However, you must take your time and add colors to each car design draft. Afterward, review the geometry vocabulary list for words and definitions that may relate to your car design or are of interest to you. Prepare to discuss 3 of the terms and their definitions, and how they may apply to your car designs. Please be clear about your terms and consider what you'd like to share. It's like you're sharing your claim with evidence regarding your car design. Okay, apprentices. Let's be creative and then share through discussion.